Hey class, Mr. Moyden here with an example dealing with finding C, which is to say in the context of a particle motion problem. I've written the problem very sparsely, so there usually be some more details here to give you some context, but I kind of just gave you the most important bits so we can focus on the math. Diving in here, you're given the acceleration as defined as a function 2 cosine of t, so we're sort of accelerating and decelerating based on the cosine wave. The question is, find the position at time equals pi if the initial velocity is 2 and the initial position is 5. So let's decode some of that. Position at time t equals pi means the ultimate question is, what is the position, p, at time equals pi? So we've got to find the position function, and then I need to plug pi into it. So that's my final answer, is going to be that right there. We're given some useful information. We're given the initial velocity, which is to say the velocity at time t equals 0, hence initial, is 2. We're not given units here, so just 2, some measure of distance per time, velocity. And we're given the position function, the initial position, so p of 0 is 5. So both of these pieces of information will allow us to individually find C through our integration process. Remember, your hierarchy here is position, velocity, and acceleration, where you go in this direction by taking derivatives and this direction by integrating. So we are at acceleration, we need to integrate to velocity, find C, and then integrate to position, find C, and finally find the position at time t equals pi. So acceleration, a of t is equal to 2 cosine of t. According to this formulation, acceleration is simultaneously known as the derivative of the velocity. So dv dt is equal to 2 cosine of t. I'm going to move my dt over here. So dv is equal to 2 cosine of t dt. Integrate both sides. So my velocity as a function of time, the integral of this, the antiderivative of this would be 2 sine of t plus a constant. So let me just check here. Sine's derivative is cosine, and the 2 is a constant multiple, so we're good. I still have this c, though, to find. So I'm going to do that by using this fact here. The initial velocity, because I have a velocity function, is 2. So I'm going to use my fact that at 0, my velocity is 2, which is to say, plugging it in here, velocity at 0 needs to equal 2, and that would be 2 times sine of 0 plus c. So remember, the sine wave looks something like this, and at 0, it is 0. So sine of 0 is 0, 2 times 0 is 0, and thus 2 is equal to c. So my specific or particular solution is that velocity as a function of time is 2 sine of t, not plus some random constant, but plus this 2 that I just found, given this initial condition. Well, velocity, furthermore, can be written as a derivative of the position as a function of time. So the change in position based on the change in position and the change in time would be the definition of velocity. So dp dt is equal to 2 sine of t plus 2. Likewise, move dt over there. So dp is equal to 2 sine of t plus 2 dt. Integrate both sides, and now I have my position function, because in a sense these are opposites. P of t is equal to, well, let's see, got to be careful here. Sine is the derivative of negative cosine, right? Because cosine's derivative is negative sine. So it'll be negative 2 cosine of t. 2's derivative will be plus 2t plus a constant. Let me just check there. Cosine is negative sine. Multiplying by times negative 2 should give me a positive 2, and there it is. 2t, of course, will just give me 2. So I still have this pesky constant. I have my position function. I still need the position at its particular time. Well, my position information was that the initial position is 5. So I'm going to use that fact here, just like I used initial velocity earlier. My initial position, so I'm going to use p of 0 being 5. So p of 0, which needs to equal 5, looks like negative 2 cosine of 0 plus 2 times 0 plus c. Well, here I've got to be careful. The cosine of 0, well, the cosine wave looks something like this. And at 0, I have a value of 1, right? So 5 is equal to negative 2 times 1 plus, this will give me 0, plus c. So 5 is equal to negative 2 plus c, so 7 is equal to c. Oops. Pull it up there. So my new and improved position function, my particular solution, wouldn't be just plus c, but rather plus 7. So position as a function of time is going back here, negative 2 cosine of t plus 2t plus this 7 that I just found based on the initial fact. The ultimate question was, what's the position at time t equals pi? So I'm going to plug pi in here, negative 2 cosine of pi plus 2 pi plus 7. Cosine of pi, this is 2 pi, this is 1 pi, so this would be negative 1. So negative 2 times negative 1 plus 2 pi plus 7. Negative 2 times negative 1 is positive 2 plus 7 is 9 plus 2 pi. And there's our position. Enjoy.